So today, um, I will be going over lab one and what I did. Uh, I'll be sharing my screen right now. As you guys can see, I set up a server and a client virtual machine, so that they could communicate with each other. Um, I was able to um, set up a virtual machine um, network between the two, uh, and that's shown here in the settings where it says custom VNet 2. They're connected to each other from that connection. Here it says custom VNet 2, VMnet 2. Um, and then I was able to establish connection between the two, the client and the server. Um, I can run the server on the server VM and the client on the client VM. Just run this, and then I'll run this. And then my message to the server will be hello. The server sends back an acknowledgement saying that I got the message, and then um, the server displays the message in the terminal. Then for the next part of the lab, um, I got the server to continuously run and wait for messages from multiple clients. This allows the server to be more of a real world server. The setup is essentially the same as the last part of the lab, except I have two clients instead of one. And I can send a message hello from one client and send a message hello too from the other client. Both are being sent to this server. And then I also added the SIG catcher call to the code so that the zombie problem is eliminated. Um, yeah, so I can go ahead and show you that. So here we run server M, which contains the code that supports um, multiple clients communicating to the server. And that allows the server to continuously run. So run that, and we'll have two of these open and do client. So it's the same client code, um, and we're sending it to the same IP address. Um, so we'll just do that. We'll send hello from this one. I got my message. And then if we go ahead and run this again, and hello too, it says I got your message. And here it has both messages and it's still waiting to receive more messages from other clients. All right. Um, and then uh, so basically, if the parent runs for a long time and accepts many connections, um, each of these connections will create a zombie when the connection is terminated. What the SIG child call does is when a child dies, it sends a SIG child signal to its parent, and then once that is sent, um, the SIG catcher function will be called. Um, which will call wait three, which will receive that signal. And then that causes the W no hang flag to be set, which then causes the uh, that to be a non-blocking wait. All right, so we can exit out of that. Um, and then for client to server communication with datagram packets, I was also able to communicate between the client and the server with datagram packets. The setup is essentially the same as the lab before. I sent two messages, hello and hello too. Um, and the server received the messages and confirmed that I got them. So we can run uh, client D. So server D. Oh, all right. So server D has the code for the datagram packet um, communication between the server and the client. And we'll use the same port, 5157. Run that. We'll use client. Uh, we'll use client D to the same IP address and then the same port. Run that. Enter the message, hello. The server got my message, as you can see. And then we can just run another client D. Um, client D. Hello two. Hello two. Um, so basically this communicates with datagram packets, which are unreliable because if a packet of information gets lost, the sender is not told that it that packet is lost. But in contrast, with the Steam Stream socket, the uh, TCP protocol will detect that the message was lost because it was not acknowledged and will be retransmitted without the process either at either end knowing about this. Um, um, we'll go over the code a little bit later, but I just wanted to show you that I got this to work. And then for the last, uh, for showing you the last thing I did, I got the Unix domain sockets to the server and the client to communicate using a socket in the Unix domain. Um, basically, the server and the client need to share the same file path. So we'll go to server for this one and open up a different window, new window, and then we can go dot slash server u, and then the name of a file path that it wants to share, and then we can go client u, um, and then the name of the uh, shared file. Enter the message, hello. Um, so the connection had been established and it sent hello. The client sent hello. The return message was I got your message. So we can see that the server and the client both established connection and exchanged data. For the code, for the code here, I wanted to show you the base client code, which was basically copy paste of what was given on the lab write-up. Um, you have an error function for error handling, and then you have um, basically taken arguments from the command line, um, find the port number, the socket, and then try opening the socket, and then find the host name um, of the yeah, find this host name that was passed in through the command line, do some error checking, and then set up the socket and then connect to the socket. Um, and then you enter the message in the command line that you want to send, and then send it over, and then to the server, and then print it out. And then read from the socket to see what the server says, um, as like an acknowledgement. Here's the base server code. Basically does the same thing as the client code in terms of like setting up the socket and binding. Um, and then it just listens for any communication from the client. Um, and then reads from the socket, sends an acknowledge message, and then prints out what it got um, from the client. For the multiple client code, it's basically the same as the base server code, um, except you add a signal call here and a while loop that basically keeps on going and keeps on listening for data communication from different clients. For the datagram packet sending, um, again, it's pretty similar to the base server code, except you change this line here, this middle uh, indicator here to support datagrams. So sock underscore dgram supports that. And then you change this to be received from and sent to, because the datagram is connectionless, basically. And then here in the client datagram code, um, basically do the same thing, change this indicator here to support the datagram packets, and then added the send to and receive from. Um, then, so as you can see, it's pretty similar to the base client and server code. And then the Unix code or the Unix socket domain code was taken from the links that were given in part 5 of the assignment. So this is the same as what was given, same with the client. Um, you do basically the same thing as the base server and client code, except you establish connection through the path that is given in the command line. So yeah, that was my lab one. If you have any questions, let me know. Thank you.